So just a quick reminder here on the equality of sets. Set A is equal to set B, provided the two conditions are met. So first, every element of A is an element of B, and there can be repeated elements, and vice versa. Every element of B is an element of A. So two sets are equal if they contain the same elements, regardless of order. So here, just a reminder, as I mentioned previously, repetition of elements in a set does not add new elements. So 1, 0, 1, 5, 3, 3 is equal to 0, 1, 5, 3 because this set contains the unique elements 0, 1, 5, and 3. So what we're going to do now is determine if these two sets are equal or not equal. So in looking at this one, these sets are not equal because the second set contains 0 and the first set does not. So I'm going to write not equal, and I'm going to write a reason. So 0 is in the second set. And then we're going to move on to example 6. So determining whether two sets are equal. So 3 is equal to x such that x is a counting number between 1 and 5. So if I rewrote those real quick, let me just write the set containing 3. And the other set over here is going to be the set containing, if x is a counting number or natural number between 1 and 5, that is 2, 3, and 4. So we can see that these two sets are not equal. So the second one, x is a negative whole number, and x is, or y such that y is both rational and irrational. So if I write this second one, if we have a negative whole number, that just gives us the set containing, well, the opposite of 0 would be 0, and then negative 1 and negative 2. And then I can put ... because that would go on for forever. And then if y is both rational and irrational, well, a number can't be rational and irrational at the same time. It has to be one or the other. So this would just be the empty set. So these two things are not equal. So here we have the set of 0, 0, 1, 1, and 2, 4. And the set x is a natural number less than 3, and the y number is x squared. So these are going to be whole numbers. And if I'm looking at here, natural numbers less than 3. So I'm just going to list the x numbers in the domain. So for our x numbers, the first natural number would be 1. The second natural number would be 2. And then we would pair it with the x squared. Well, 1 times 1 is 1, and 2 times 2 is 4. Now, this would be the second set, so I'm going to put those there. And what I want you to notice is that 0 is not a natural number. So you might have thought that it was, or that these were whole numbers here, but these two sets are not equal because 0, 0 is in the first set, but not the second set. So we can write that down too to justify our answer. 0, 0 is an element of the first set, but not the second set. So now what I want you to do is work on the practice problems.